Hello. For Legacy Code Base Week at Gauntlet, I chose to work on Quantum Espresso, an open source command line tool for running quantum mechanical simulations. It's primarily written in Fortran. One of the biggest frustrations of using this is setting up a complex simulation, letting it run for a few hours, and then realizing that you made a mistake somewhere in the setup. With that in mind, most of my added features are around the execution of a simulation. I'll walk through the features on the command line first, then show you kind of a nice user interface I built that makes it easier to see what's happening. To start, this is what a typical input file looks like. You can set the calculation type, a number of parameters, and then some information about the atoms. So we've got two silicon atoms here at different positions. The first feature I want to show is the auto optimize features. So if these are set to true, one part looks at the size and atoms in your structure to determine how finely the space should be measured. The other part runs a series of quick calculations to determine the right cutoff energy, past which point you're not seeing much return on increasing compute power. Um, we're going to run this, and then you'll see the these optimizations then appear in the output as you're running. So this is great. The next feature I added was a geometry check. This checks whether your arrangement of atoms has any oddities, like two atoms being way too close together, or in this case, we've got an atom, um, as you can see here, sanity check. We've got one atom appears to be isolated. There's no, it's kind of far from its nearest neighbor. So this continues to run the simulation because you might have done this on purpose, but it still shows you the warning so that you know, so that you can check that this is indeed what you wanted to do. Next, I wanted to interrupt the simulation itself while the simulation is running. Get one going here. You can type a command to, yeah, we'll go with this one. You can type a command. I got to do this before I start because it takes a little bit of time. It doesn't take very long to run. So there's a command to type that lets you grab a snapshot, get a current state of the simulation, and then another command that lets you gracefully pause the simulation so you can start it again from a checkpoint. So we'll start this. I'll type in this command to get a snapshot. This will, take a second, wait till the next iteration runs, then give me a snapshot of what that looks like. Then I'm going to see if I can get this to. Okay, good. I think I gave it enough time. Yep, and so we have the soft pause requested. So at the next checkpoint, we've got 5 iterations completed, but we've stopped it. And so I can restart the simulation by adding this flag resume from. So if I go back and run this, here we got the resume from flag here. So it'll restart. So just to scroll up a bit here, the snapshot is good. It gives you a little bit of information here, but it should be enough for kind of a regular user to be able to tell if this is going the way they want it to or kind of wildly off. Then they can figure out whether to stop it and restart. And then the snapshot is nice if you're working on shared resources or limited resources. You might need to stop it and start it again so that someone else can use it, or because you've got kind of limited time using this. I've run very quick calculations here, but some of the ones you put in a research paper take a lot longer to run. Again, could be hours, even days. So I am going to pull up. This is the user interface I built. This makes it a lot easier to see and deal with things. So to start on this dashboard, you can kind of see some previous things that I've started. We're going to start a new simulation. Um, Here, basic settings, we'll give this a name. Say carbon. We'll do something with carbon here. You can pick the type of calculation you want to run. You can change the lattice. This is kind of the space. Well, I'll make a change so you can see what this looks like when I do it. Oh, did not mean to push enter there. Here we go. We'll change this shape, rename this carbon. And then as you're adding atoms down here, we've got atoms, the element and their position. Keep that one at 0, then we'll put this somewhere else. You can visually see what you're doing. So you can see this box looks a little short on one of the angles. This is the lattice. This is, if this is a crystal structure, this is how the unit that repeats. You could imagine so many of these next to each other and on top of each other. Like this is a solid material. Um, let's go through some of these other ones. So there are some different ways that we are estimating these carbon atoms and their valence electrons in their system. We can either auto-optimize or set some of these parameters. Again, even as I'm going through all this, you've seen these before, but it's just nice to have labels and checkboxes and sliders instead of that raw text file, that raw input. So we'll have the convergence here, and then we will create the simulation, and then we'll run it as it is running um, on the software. We'll see some messages in progress here once it loads. It'll take a second here. Got probably way too many tabs and other processes running. Um, this is going a little slowly. Here we go. Yep, we've got um, our regular messages here. We've got total energy here at the end. This is all great. Future add would be to integrate some visualization tools. There are a lot of tools to then visualize the results, but Quantum Espresso specifically just deals with the computations itself. Um, so I packaged both Quantum Espresso and this web interface into a Docker container. So this will be really easy to kind of uh, install and run as a single thing on your own. So yeah, hope you enjoyed this. This was a lot of fun to work on.